Today we are covering section 11-6 on inverses, or just inverse, versus direct variation. Now you may or may not have ever heard of inverse versus direct variation before, but let's break it down to what it sounds like. So variation, the root word there is vary. So it's talking about the two different ways that something can vary or change. That's what vary means, change. Okay, so essentially what it's talking about is the two different ways that y can change depending on what x is. So the first one we're going to talk about, the much simpler one, is direct. And how you know something is direct variation is it has this equation y equals kx, where k is a constant, meaning it's a number. So for example, y equals 2x. That's direct variation because it's of the form y equals some number times x. Y equals 5x. That's direct variation. Y equals negative 3x. That's direct variation. You're just multiplying negative 3 times x. Y equals 1/2 x. That is still direct variation. You're multiplying a number times x. So let's look at what one of these looks like when you put it in a table. So let's just take y equals negative 3x, for example. And suppose we make a table out of it, an xy table. We'll use 1, 2, 3. We'll just go up to 3 this time. Okay, so if this is our equation, y equals negative 3x, and x is 1, then y equals negative 3 times 1, negative 3. When x is 2, y equals negative 6. And when x is 3, y equals negative 9. So let's see what's happening here. So as you go from one number to another, so as you go from 1 to 2, you're multiplying 1 by 2, and you're getting 2, right? The same thing is going to occur with the corresponding numbers. So how you get from negative 3 to negative 6 is you multiply negative 3 by 2, okay? Same thing works if you're going from 1 to 3. How do you get from 1 to 3? What do you multiply it by? 3. How do you get from negative 3 to negative 9? You multiply it by 3. So the rate of change here is consistent between x's and between the y's. So how that would look on a graph, if you were to graph this, I'm going to scale my y's by, let's see, 3's. So we'll say 3, 6, 9, negative 3, negative 6, negative 9. And then we'll just scale our x-axis normally. 1, 2, 3, negative 1, negative 2, negative 3. All right, so we have the coordinate 1, negative 3. We'll rewrite it over here to look a little nicer. 1, negative 3, 2, negative 6, and 3, negative 9. So if you were to graph those, 1, negative 3 is right here, 2, negative 6 is here, 3, negative 9 is here. If you were to plug in a 0 for x, you would get 0, okay? So clearly this is making a straight line. So you will know something is direct variation by looking at the graph, because direct variation always makes a straight line. And always goes through the origin, which is the point 0, 0, the origin. Okay, if you don't have, if one of those things is missing, like maybe you have a straight line and it doesn't go through 0, 0, it is not direct variation anymore, okay? It's something completely different. So that's an overview of what direct variation is. Let's go into inverse variation now. Okay, so inverse variation is similar to this equation, but instead of y equals a number times x, it's y equals k times 1 over x. So y equals some number times 1 over x. Or you might see it written as y equals k over x. Those are equivalent. That's the same thing. Okay, this is inverse variation again. Oops, I didn't write this over here where k is a constant. Same thing over here where k is a constant number. So it's just a number. So again, we'll do some examples. So y equals 2 over x. Y equals 5 over x. Okay. Y equals 1/3 times 1 over x, which would be 1 over 3x. Okay, that's just using this form over here. Y equals -3 over x. Okay, so looking at these equations versus these equations, the starkest difference that you can see between them is that in this case, there are no fractions. X is on the numerator, everything's on the numerator unless you have a fraction as your k term. But otherwise, everything is on the numerator and it makes a straight line. However, over here, all of the x's are on the bottom. They are all on the denominator. So that's the biggest giveaway as to whether or not it's direct or inverse variation. If x is on the top, it's direct. If x is on the bottom, it's inverse. Okay, so let's make a table with this one now. Let's use y equals 2 over x. So if you were to make a table for this, x, y, we're going to make it a lot bigger than this table, and I'm going to show you why in just a second. But let's use -6, -2, -1, 0, 1, 2, and 6. We're gonna need this big table in a second. Okay, so plugging in the x values, 2 divided by -6 reduces to 2 divided by -3, or sorry, 1 over -3, which is just -1/3. 2 divided by -2 is -1. 2 divided by -1 is -2. 2 divided by 0, you can't divide 2 by 0. That is what we call undefined. 2 divided by 1 is 2. 2 divided by 2 is 1. 2 divided by 6 reduces to 1/3. Okay, now this graph is going to look very, very different from anything that you've ever seen before. Okay, so if we were to graph this guy, it's going to give us what's called a rational function, or it is a rational function. A rational function means the x is on the denominator. Whenever you graph something where your x is on the denominator, it's going to have this general shape that you're about to see. So let's see. So -6, -1/3, 1, 2, 3, do the same thing over here. 2, 3, 4, 5, 6. Hopefully you guys have some graph paper at home. That would make this a lot easier for you. And then we'll scale this by 2s. 1, 2, -1, -2. All right, so when x is -6, y is -1/3. So -6, -1/3 is approximately here. When x is -2, y is -1. And when x is -1, y is -2. Okay, and I know you don't know this yet, but if you were to plug in more points, it's going to make this shape. Just like that. Until it hits 0, because remember at 0, it's nothing. There is no y value when your x value is 0. We'll get into that, has a specific name for it later. We'll get into that next section. But let's graph the rest of it now. So we have 1, 2, 2, 1, and 6, 1/3. And that's gonna look like this. Okay, so this is the general shape of a rational function. All inverse variations are rational functions, okay? So if your graph looks like this, a nice normal straight line through 0, 0, it's direct variation. If it looks something funky like this, where you have two graphs going in squiggly directions like this, then it is inverse variation. So the last thing that I want to cover, we covered how you can tell if it's inverse or direct looking at the equation, looking at the table, looking at the graph. The last thing that I want to cover is when the functions, when it's not exactly obvious. So, for example, 1/7. Go ahead and copy these with me. -3 xy equals 1/10. 9 times 1/m equals n, and b equals 1/3 minus a. So I'll do the first two with you. So you might get asked, are these direct or inverse? And so what you're going to have to do is say, well, neither of these look like any of the forms that I showed you before. Neither of these look like y equals kx or y equals k over x. So what you have to do is solve for one of the variables. It doesn't matter which variable you solve for, just solve for one of the variables. Get one of the variables by itself on one side of the equal sign, and then you'll be able to tell if it's direct or inverse. So here's what I mean. In this first equation, I'm going to solve for m. So to solve for m, meaning getting m all by itself, I'm going to multiply both sides by n. When I do that, these two n's cancel, leaving m all by itself. And this becomes 1/7 times n. Or in other words, y equals kx. So some variable equals some number times a variable. Y equals kx means it is direct variation. Okay, AB equals 3. So again, we have to solve for one of the variables. It does not matter which one. Let's solve for A. Why not? So to solve for A, divide both sides by B. When you do that, these will cancel, giving you A equals 3 over B. So in this case, the B is on the denominator, meaning automatically it's going to be inverse variation. Okay, pause the video, try these three on your own, and then start up the video again and go ahead and see if you got it right. Pause. Okay, hopefully you paused. divide by, you can divide by either y or x. I'm gonna divide by x, divide by x. How do you divide a fraction by a whole number? You multiply by the reciprocal. Y equals 1/10 times 1 over x, or in other words, keep, change, flip. So now our x is on the denominator, so we know it's inverse. Okay, over here, we already have a variable isolated. So since this is isolated, we see that m is on the bottom, so automatically we know it's inverse. Okay, and then over here, whenever you have a plus or a minus sign, you automatically know it is neither direct nor inverse. Okay, direct and inverse variation only ever deal with the multiplying or dividing sign. The second you see a plus or a minus, you know that it is going to be neither direct nor inverse. Okay, go ahead and try your practice problems now. I will post the answers on PowerSchool. Make sure you are showing your work. Also make sure you are uploading these notes and then the practice problems right underneath them, just like this. Good luck.